Yeah. So it's an MSR question. Again, for our convenience at this time during the webinar, I have put the data of all the 3 tabs side by side. Of course, it makes things a little easier for us. But the main point over here is to explain what to do, what happens when you read the first tab, etc. So let's do one thing before we jump onto the questions. Let's discuss what the MSR tells us. Yeah, let's discuss the data given to us. So when I looked at this tab 1, and we know how to solve an MSR question now. What do? We look at tab 1 within the first 10 seconds. Then we go to tab 2. We see what kind of data is given in that. So I see that there's again some text given to me. Then we go on to tab 3, and then we see what kind of data is there. So there is a table given to me. All right. So then essentially, in case I do want to put some data together, and I do want to scribble a few things, it will happen in my tab 1 and tab 2. I know that there's some kind of a table in tab 3. So of course, that is the tab that I am going to stay in case I use that strategy, right? All right. So then, let's look at the data given in the first tab. So 2 amateur wrestling squads, squad A and squad B, competed against each other. Each squad had the same number of its members who were contestants. In the competition, each contestant and squad. So, immediately when I see that there is like this one group and there is this second group, now this is natural that I would end up making these circles. I would say this is A and this is B. Even though later on I realized in this question that I needed to make some edits to the circles, to the diagram that I make, but then still there's no choice, because this is how I'm going to really understand what is given to me, right? Without wasting too much time. I don't have to go back to text, but going back to a diagram, I can see the relations between variables. So of course, I'm going to make something like this, yeah? Then says in the competition, each contestant in squads A and B wrestle against exactly one contestant in the other squad, and no non-contestant member of either squad wrestle. So essentially, they're saying that there's a smaller group in each. Now this is a group of contestants, and here there are some people who are non-contestants. So basically, trainers, etc., etc. And then they're saying that each one person from here wrestle with one person from here. So there was this 1:1 relationship going on. If you remember your domains and ranges, so this is the diagram that it should look like that, right? So essentially what we have is a 1:1 relation. One person from here, it wrestles with one person from here. Fine. Okay, now let X be the proportion of squad A's members who were contestants in the competition. So we're saying that X% of this A, they were in this circle who were contesting. And let Y be the proportion of squad B's members who were contesting in the competition. So I would say that Y% of B, right? They're giving it in terms of fractions, right? So that's fine anyway. So if Y would be like a 1/4 or a 1/10 or something like that. And similarly for X also, it doesn't matter. Right, in terms of who are contesting the competition, yeah. In terms of X and Y only, what is the proportion of the total number of members in the 2 squads who were contestants in the competition? So now we are saying, look, it seems like an average problem now, right? That there are X% or X fraction of members over here are contestants, that is this, and Y fraction are contestants over here, which is here. And now they are saying that, okay, if you combine them, then total contestants upon total number of members in the squad A and B, what is that fraction, right? That is what they're asking us. But then it's odd, right? What is this question? I was wondering when I read this, and I was wondering in terms of X and Y, and then it ends with the question mark. What is it? Yeah. Then I look back at the header that, okay, what is it that they are actually discussing? And that is when I noticed that they are talking about a problem statement. Then they are talking about a concise solution, and then they're talking about a tab. So they're talking about a problem, and then over here in this tab, they have given me the problem. So in concise solution, they would, give me perhaps some kind of a solution to this problem, right? So then it made sense that, okay, why is it ending with a question mark? Because here we have a problem. We have a question over here, right? Okay, then we went to the solution. Then let's go on to the second tab. Now, this is the, data that I have from my first tab. Okay. The second one, let A and B be the number of members of squad A and squad B respectively. So then, look, I am given that I have A members here and I have B members over here of the entire squad. And let A dash and B dash be the number of contestants of squad A and squad B respectively. So then the contestants, that is people over here, that is A dash, and the people over here write it outside, that is B dash. So this is the smaller circle is A dash, and this smaller circle is B dash. All right. In the two squads, clearly A dash is XA. Now, of course, I know that this is the fraction of the, this entire set that is actually contesting. So it makes sense that A dash is XA. And of course, by the same logic, we'll have B dash is YB. Makes sense, right? Okay. Also, XA is equal to YB. Now, they are giving us the solution, right, of this particular problem. So they're giving us all the steps of solving the question, how to get this, essentially how to get the answer to this. Now, why is XA equal to YB? Because we have been given over here that, X we don't know. So each squad had the same number of its members who were contestants, right? So this circle is equal to this circle they have given us. And since this circle is A dash and this circle is B dash, so we can say that XA is equal to YB. Makes sense what they have done right here. So also XA equal to YB. Now, in case you have doubt, you should go back and check why did XA equal to YB come over here. Ensure that you understand the solution that they have given, right? Therefore, the ratio of the total number of contestants in squads A and B, total number of contestants in the squads A and B, contestants, that is A dash and B dash, to the total number of members in squads A and B is XA plus, makes sense, right? Because total number of contestants is A dash plus B dash and total number of members is upon A plus B. And now this A dash is nothing but XA plus YB upon A plus B, right? So I get this, which is equal to, then they're saying this is equal to 2XA upon this. Now, how did we get this? Look, the difference between this and this, how do I go from one step to the other? I say the difference between these two is simply that there is no B over here, right? Where is the B gone? Okay, now since they have given me this relation XA equal to YB, then probably they have used B is equal to XA upon Y. That is why the B is missing here. If I try and put XA upon Y over here, Y will get cancelled. I'll have another XA, so I have 2XA, makes sense. Then over here, if I put XA upon Y, I get A plus XA upon Y. Perfect. So this makes sense as well. So then their solution, the way they have given up to now, it makes complete sense. There's nothing incorrect in the solution, right? In case I have a question based on that, right? So then I have a problem and they have given me a solution to that problem in two of the tabs. What is the third tab now? That is a table. For each of the several pairs of possible values of X and Y. Now, these are the possible values of X and Y that they have given us, right? Look at the table. For each of the several pairs of possible values of X and Y. So, one is that X is 1 by 4 and Y is 1 by 4, X is 1 by 4, Y is 1 by 3, etc. Right? They have given us, for corresponding X and Y, they have given us some, like, for example, when X is 1 by 4 and Y is 1 by 3, they have given us something 2 by 7. Let's see what that is. So they are saying that for several pairs of possible values of X and Y, the table gives the value of this XA plus YB upon A plus B. So it gives us the average that we were looking for, right? This average that we were looking for, not in terms of X and Y alone, of course, that's fine. But this is pretty much the average that we were looking for. So these various values are actually the averages, XA plus YB upon A plus B, which designates the proportion of the total number of members in the two squads who are contestants in the competition. So this tells us that 2/7 were contestants out of the total number of members who were there in the two squads, right? When X is 1 by 4 and when Y is 1 by 3. So the values of A and B are like that, such that in this case, they gave us a 2 by 7. When, they took X as 1 by 4, they took Y as 1 by 3 and some values of A and B, whatever they did, they got the answer as 2 by 7. Similarly, of course, when X is 1 by 4 and Y is 1 by 4, please recall your weighted averages, recall your averages, when you have to find the average of 1 by 4 and 1 by 4, it is going to be just 1 by 4, right? So then, of course, then this value is 1 by 4 only. Similarly, half and half, this value is also half. So then essentially the values are making sense to me. In case I'm looking at the table, the values are making sense to me. Now note NP is used for entries that are not provided in the table. So they're saying that these entries are not provided. right? Not that these entries, there could be a question or whatever, but they're saying that these entries have not been given to you. Not that we cannot calculate it or anything, just that they have not been provided to you, right? Okay, so I understand the table. I understand all the three tabs now. In case there is any problem, ask me, but try out the first question now. I hope you can see it clearly. Let me know in the Q&A in case you cannot read the question or there is any problem. Try it out. Good job. They were good. Yeah, Agnes, that's good. Okay, let's try it now. Which one of the following procedures, when applied to the last mathematical expression in the concise solution tab? So the concise solution tab is our second one, right? It's right over here. And to the last mathematical expression. So which is our last mathematical expression? It is this one. Gives a mathematical expression that answers the question asked in the problem statement tab. Okay, so, from what we could see, I mean, the answer was pretty much there, but then let's read exactly what the question wanted. It said, in terms of X and Y only, in only these terms, what is the proportion of the total number of members in the two squads who were contestants in the competition? So the point was that they wanted the answer in terms of X and Y only. So let's look at what we have got. We saw the procedure, we went through the entire solution and we said that, okay, it all sounds good and there's, no error over here. So now, what step can we apply over here such that we get this expression in terms of X and Y only? I say that there is an A extra over here, right? So then how do I get rid of A? But now see that I have an A in the numerator and I have A in both the terms of the denominator, which means that I'll just, cancel out the A. I say 2xa upon and I take A common here and I say 1 plus x upon y, right? And then A and the A get cancelled and I know that I get my expression only in terms of x and y, exactly what was asked, right? So my step is that I have to cancel out the A from the numerator and the denominator, right? Okay. Look at the options. Multiply both the numerator and denominator by A. No, this is not multiplying both. In fact, we are dividing both numerator and denominator by A, right? This is something, we say that, okay, we are just canceling out. Essentially, when we learn it in elementary school, what do we say? We say that, or middle school probably. What do we say? We say that we are dividing both by the same number, both the numerator and denominator by the same number, right? So essentially, I'm dividing this whole thing by A and I'm dividing this whole thing by A, and that is why I'm saying my A's are getting cancelled off, right? All right. Now multiply both the numerator and denominator by Y. Of course, now divide both numerator and denominator by A, right? So exactly. So this is what our step was, right? Then subtract A and then divide, well, nothing like that, and divide by A upon this is also nothing like that, right? But it was a very, very simple step. We just had to take our A common out of it and then cancel out the numerator and denominator, or in other words, divide numerator and denominator both by A. Make sense? Right? Okay, let's go on to the next question over here now. We're going to lose the diagram. Okay, anyway, take a look at the question. I'll just make the diagram quickly once again. Let's say here, A and B. This is A dash, this is B dash. X and Y, we said A dash is X and B dash is YB. So, YB. And this is the only slightly tricky question of the set. I'll give you another minute. I've not got any responses yet. Let's try it now, guys. It's okay. Yeah, a given number is a possible value of A dash if, okay, so a given number is a possible value of A dash. So essentially, perhaps we're looking at these as values of A dash, okay? If for each value of X in the table tab, so this is our table tab, for each value of X in the table tab, so these are our values of X, right? This in the first column, this side, these are our values of X. There is a value for each value of X. There is a value of A that is compatible with that value of X and the other information provided. So I'm looking, a given number is a possible value of A dash. I know how do I calculate A dash in terms of X and Y. X and A dash is equal to XA, right? They're talking about this particular relation. So they're saying that A dash, a value is a possible value of A dash in case for each value of X in this table, which are the various values of X, these all are the values of X. there is a value of way A that is compatible with that value of X, right? There is a value of A possible. Basically, they're saying for each of these values of X, there should be a possible value of A. And if there is, and if it works in this particular equation, then that value is a possible value of A dash. Like, for example, forget the given value. What are they talking about? Essentially, we'll look at that. So let's say when X is equal to 1 by 4, right? What is a possible value of A? Think about that. I have a value of 1 by 4 for X, right? I know that can A be, for example, 3? What is A? A is the total number of people in the team, fine. But A dash is the number of contestants in the team. So in case I say that A is 3, number of contestants is 3 by 4, but that is a fraction. It's not an integer. But number of contestants has to be an integer, right? It's a real life scenario. It's a real life situation, which means that this cannot be 3. This must be either a 4 or then a multiple of 4. Does that make sense? Is that okay? Why? Because I want an integer value for A dash, right? So they're saying this means that 4 and 4 can get cancelled and I can get a 1 over here. So 1 is a possible value for A dash when X is 1 by 4. Just 1 by 4, I've not looked at other values, right? So this is what they mean by this first sentence. Is that clear? What is a possible value for A? Yeah. All right. I'm going to erase that because we'll need more space. Okay, for each of the following numbers, select yes if given this condition, it is possible value of A. Now this needs to be, I have to say whether this is a possible value of A or not, each one of these. I have to first say 9, is 9 a possible value of A dash, right? I'm looking for a possible value of A dash. Okay, so which means all I have to think about is that 9 should be of the format XA. Makes sense, yeah. Now, X can take various values. Which are those values? It can be 1 by 4, 1 by 3. Guys, of course, we're not going to write all this in the test. I'm writing it just to explain it to you, right? X can be 1 by 2. I'll just look at these particular values. I'll say 1 by 2, 2 by 3, and 3 by 4. So I say 2 by 3 and 3 by 4. These are the various values that X can take. And then for each of these values, there should be a possible value of A, which is going to give me 9. Is that okay or not? For each of these values of X, there should be a possible value of A. Well, here there is no problem, right? I can easily get a 9. How? If my A is a 36. Make sense? It's just, think about it, right? What will my A be so that when I multiply it by 1 by 4, I'm going to get a 9. Of course, it'll just be 36. So this is possible. Okay, now can I get a 9 if my X is 1 by 3? Look, all I have to do is I have to say this is 3 into 9, right? I say that I should be able to cancel off this 3 and I should be left with a 9. I don't have to actually solve all this, right? I just have to think about it. Fine. A 1 by 4 into something will give me 9. Certainly, it's not a problem because I'll multiply this 1 by 4 by something which has a 4 to cancel off my 4 over here so I don't have a fraction, and then into a 9 to get me a 9. Yeah? Half into, certainly again half into 2 into 9 will again give me a 9. So of course my A is, if it is 18, then again there is a value of when X is equal to half. What about when X is equal to 2 by 3? Now I multiply 2 by 3 with which number so that I get a total equal to 9, and this number has to be an integer. Yeah. What 2 by 3 of what will give me a 9? I know this 3 has to get cancelled off. Fine. I know this 3 has to get cancelled and there is a 9 has 2 3's in it, right? So a 9, but I have a 2 also over here, right? My 9 is not a multiple of 2. It does not have a 2, and that is why there is no such value of A. Do you understand that? Yeah, this is the main, the core point of this question. That when I have a 2 by 3, when my X's value is 2 by 3, then there is no such value of A, an integer value of A, of course, such that it will give me a 9 because I have a 2 over here. I have a 2 in the numerator. So whatever I multiply this with, I have to retain that 2 over here, right? This 2 doesn't get cancelled off anywhere. Then this 2 has to come as it is over here, but 9 doesn't have this 2. So then this is certainly not possible. Then there is a value of x, that is 2 is equal to 2 by 3, for which there is no value of a, and that is why 9 is not our solution, right? So we select no over here. Yeah. Now, using the same logic, I'm just going to think about, we'll obviously not do all this work. I'm just going to look at it over here. I say just like for this value, my 9 did not work. For this value, my 10 will not work. Next option is 10. Why? There is a 3 in the numerator. When I say 3 by 4 into a, this should give me a 10. A has to be an integer. Where is my 3 then? My 3 has to be maintained, right? I can't cancel off my 3 with anything. If a were a fraction, for example, this was a fraction, I would say 40 by 3, then that's fine. But a has to be an integer, so 3 doesn't get cancelled off. So the 3 has to come as it is over here, and it can't, right? Then if x is equal to 3 by 4, then 10 is also not a possible value. Yeah. Now, so here also I choose no. Look at 12 now. Of course, I know, with 1 by 4, 1 by 3, 1 by 2, everything works because my numerator is just 1, right? 1 by 4 into something will give me 12. I'll just multiply this by 4 into 12, right? My numerator over here is 1. There's no complication. But when I have a 2 by 3 or a 3 by 4, that is when I could have a complication. But my 12, it has a 2 and it has a 3 as well. And that is why 12 will be a possible solution. It will work, right? If you want to look at it, say 2 by 3 into something which is going to give you 12, this 2 has come here as it is. So this is a 2 into 6, which means here I've multiplied this with 3 into 6. So when this got cancelled, I got my 12 over here. And similarly, if I have a 3 by 4 into something which is going to give me 12, again, this already has a 3. So this 3 came here as it is, and there was a 4 also, which means I multiply it by 4 by into 4. That is, my a is 16. So this gets cancelled and this becomes 12. So for every value of x, I have a possible value of a, which is going to give me a value of 12. So that is why 12 works. It doesn't take a lot of time, guys. It's a matter of developing intuition. Automatically, when you look at these values, you'll say, hey, 1 here, no issues, no problem. I can multiply it with an integer and get any of the integers. It doesn't matter. But here and here, I need a multiple, whatever my answer is, it needs to be a multiple of 2 as well as a multiple of 3. So 12 works. Is that all right? Are we good here? Any doubts here? Okay, then let's go on to the next question. If you remember, I'll just put down again, and b dash is equal to yb and x is equal to yb. Yeah, Tejal, Rob, Devanshi, Agnes. Everyone is correct. Fairly simple, this one. Yeah, so what does it say? A dash is, it says assume the information provided is true for each of the following mathematical statements. Select yes if, according to the information provided, this statement is true for the possible values of x and y, otherwise select no. So we have to select yes if this is true. A dash is equal to yb. We know A dash is equal to xa and xa equal to yb. So, well, yes, so this is true. A dash equal to b dash. We know that xa equal to yb and A dash equal to b dash, right? We know that the contestants are the same in both the teams, so that is why this is also yes. And a plus b is less than xa plus yb. Xa plus yb are the smaller, x is a fraction, right? It's a small part of your a, and y gives you a dash is a small part of xa and b dash is a small part of of b, right? So then xa will be smaller than a, small or at max equal to a. In case let's say x is 1, then at max equal to a, and yb will be smaller than b or at max equal to b. So of course, then a plus b cannot be less than xa plus yb. So of course, your answer will be no. Right? Perfect. Any issues here? Let's move on to the next question.